Hi, and welcome back to Querex. My name is Patricio. I'm the software engineer and AI lead in this company. And today we're going to be using one of our tools, which is the statistical tool. Now, you might be asking yourself at this point, but why somebody will talk to me about statistical tools when I have R, Python, and basically I can Google, I can use VS Code or anything to do an analysis like that. Well, you are not so wrong, and that profile of work, what you just described, like sitting in front of a computer, working with Jupyter notebooks and running R or Python, basically is for a data scientist doing a very deep and very, very extremely heavy kind of job. But in reality, today, thanks to LLMs and the tools that we built, you can have a conversation. And the focus of our company is that you can speak at the speed of thought, basically. Like if you have an idea and then you get an answer immediately. So now we're going to be talking about one of our products, and that product is the statistical server. And this statistical server is quite complex. It has a lot. So I will just right now take this one. I'm going to make it a bit bigger and I'll say, can you describe the MCP statistics? So now it will take a few moments and it will make a summary for you. While it's at it, I'm going to give you, okay, it came out immediately. So now you can see, so now the LLM has access to quite a few tools in the statistical world. You have the scripted statistics, weighted geometry, harmonic means, scores, you name it. Hypothesis testing, something that we're going to be using very soon here. Probability distributions, correlation and regression, model assessments, advanced analytics, resampling. This is something that you might not, you're not familiar with it. Doesn't really matter. That's the whole point with the tools that we built, that you don't really need to care much about it. You're having a conversation with a machine that is very, very smart and have this state-of-the-art tools. So you see that it has quite a lot, like a lot of things that you can do. And the dataset that we're going to be using today is a dataset that is published here in Norway by the Wine Monopoly. And for those who are not familiar with the Wine Monopoly, I will not write it here. The Wine Monopoly is the state-owned company that sells liquors. Everything that is above 7% alcohol, if I'm not wrong, must be sold through the Wine Monopoly. So if you like, for example, Absolute vodka, and you want to buy it here in Norway, well, you will need to go through the Vinmonopolet or the Wine Monopoly. And then you can just click here and buy it, shop, right? But this company, this state-owned company, published the sales per month and by category. So basically you have red wine here at the top, white wine, rosé wine, sparkling wine, which is champagne and that kind of stuff, beer, spirits, fortified wine, and some alcohol-free stuff, and so on and so forth. So yeah, you can basically say that we have really, really good products through the Wine Monopoly at a very good prices as well. So yeah, it is what it is. So, but the most important part for us is that we have the information, right? Now, the Wine Monopoly sells in Norway. Norway, as you know, is in the Nordics and it's a very long country. And we don't have the sales of the Wine Monopoly are not split by regions. So it's basically just sales by month and by category, and off you go. So we're gonna do a little bit of, for the sake of argument, we're gonna do an analysis on white wine, rosé wine, and sparkling wine. And we're gonna try to see if there is any correlation with temperature. And for that, we're gonna use the historical temperatures that you can find if you go to er.no. You will find, if you click here, that you can go to historical data, and now you can see, for example, November 2024, December, and so on and so forth. And since Oslo and this region basically consumes quite a lot of the percentage, we're going to use it as a proxy. I know that it's not really statistically sound, but we just for the sake of the argument, right? So we have all this information going back to 2010 or 11. And we're going to basically have we have an hypothesis, and this is very important. Like, you sometimes as a business owner, you have a hypothesis. And this hypothesis, you want to contrast them with real data, with real information. And if you want to have if you are a brand manager from a wine company, it will be very difficult for you to start Python, Jupyter Notebook, install packages left and right. You don't have the time. Probably you don't have the machine to run that kind of modeling. And you also have no interest in that. You just want to have the insight, and the insight on the fly. So this is what we are going to do right now. We're going to just use this information that is already, and if you don't know how we did that, you can look at the other videos from before, so you can understand how we connect. So now we're going to go and make the hypothesis. Like, well, I'm gonna say, let me put it in widescreen so now we can see this. Well, I have an hypothesis. Doesn't really matter. Okay, the temperature rise due to global warming is pushing the sales of white, rosé, and sparkling wine. Can you exhaust all statistical venues to prove or disprove my hypothesis? Doesn't really matter. It will understand them. The machine will understand what I'm saying. So now, what's going to happen is, like, the machine will say, okay, let's go. And we'll start gathering the data, and we'll see what happens. One of the things that you can see here is that the model that we have built in the Vinmonopolet, this is Power BI by the way, you have the average temperature, you have the max temperature, the measured the measurement, the mean, the max. You have the standard deviation. You have also the set score anomaly, the temperature anomaly label. So you can, a business owner that doesn't have interest in statistics, he can just look at it and say, oh, okay, that was extremely hot. This is always 2.3 standard deviation from the mean. And then you have the liters anomaly. So basically, if it was normal, so basically what we're trying to say is that if it's extremely, extremely hot, we should have something that is not normal. So something that is like 1 or 2 standard deviations. So it will be a correlation between these two, and probably a causation because of the high temperature, right? So this is a bit of the idea behind this thing. So now let me just go back and let's see what happened. So now I'm going to expand this and let's see what the machine is saying. I'll help you rigorously test your hypothesis that rising temperatures due to global warming are driving increased sales of white, rosé, and sparkling wine. Let me design a comprehensive statistical analysis plan. So if I see here that it created a few things, it will try to gather more information. Now it says excellent, and now I have 178 months of data. So now it's creating all the analysis. So you can imagine that if you wanted to do an analysis like this, at this point, you will need first a data scientist or machine learning or a person with a background in statistics. And that person will receive that email, will open an email from that manager, and it will begin doing this analysis. And this analysis will take through the traditional method of pulling all the data, cleaning the data, the data mining process, right? It will take quite a few days. And then it will basically reply back. So what we are doing here, since we started in about a couple of minutes, the machine already got all the data set, the entire, all the observations, already run a correlation analysis, a regression analysis, and it actually already found there is a weak correlation. So it seemed that we need to wait a bit more, but now you can basically see the reasoning of the machine step by step, and it's taking a couple of seconds. So now you can see here that it runs a simple linear regression, and it's getting the information that we want to use, basically. Now, one of the things that we do in our company is to try to bring the best of mathematics and the best of algorithms, and also everything that is close to the metal. And when we say close to the metal, we mean that the MCP that we are coding, there is no layers and there is no abstraction. It's either run in C++ or C# at worst. So what I mean by that is that we are not importing Python, we are not importing R, we are not importing packages. Everything is basically written from scratch, and is able to do this kind of analysis. And this is very important because if you were to do this analysis in the traditional way, you will not be able to have a conversation. Like you have a conversation, you have an hypothesis. Okay, I see there's a weak correlation. Then you will say, why is that, and so on and so forth. And in this case, we went full on, and I said, go deep, deep, deep. And the machine understood that this is not anymore a conversation. It understood that it wants to go to the depth of analytical, statistical analysis. So right now, it has completed 4 out of 9 steps. And now we just need to wait. And if you want to see what it's doing, first you want to extract the historical data. You're going to run a correlation analysis. Then it will run a trend analysis. Then it's going to create a regression modeling. Then you're going to create a hypothesis testing. a time series analysis, a distribution analysis, an anomaly detection analysis, and then it will synthesize all the findings immediately. And once again, this is running in a business computer, like a thin and light computer. And there is nothing really special about this computer. This is not a workstation. You don't need a lot of RAM or anything. This is meant to run, first of all, locally in your environment. So in a real world, you probably have sensitive information, right? And you don't want this information to leak in the outside your anywhere to my company or any other company. So what we have here is this MCP runs locally. And by running locally, the only responsibility from your side is that your AI provider, in this case from our side is GitHub Copilot Enterprise or Cloud Enterprise. And why I say enterprise, I mean that when it's an enterprise license, the company will not use your data to train. It will not. It has a compromise that all is anonymized, etc. But you can go even further and say, no, you know what? I'm not going to use Claude. I'm not going to use any of this. And you can click on Manage Models, and you can connect to your own private endpoint. That will mean that you have a contract with Amazon, with Azure, and you will be able to run your own endpoint of Claude, your own endpoint of Gemini, or I don't know, like whatever model you want, as if it was your own compute. But if you want to go even further than that, then you can buy your own node. By node, I mean a GPU cluster. Those cost around $100,000. You can in Norway around, let me think about it. It's 10 million, 8 million Norwegian kroners plus 25% tax, and then you can buy your own endpoint. So that will mean that if you work in defense or in some very secretive kind of company, you can buy your own machine, completely disconnected from internet. You download a model, put it in that machine, and then you connect directly through that. So you have the MCP running completely locally in your machine, and you're connected completely locally to a LLM model. And now you have these models that are simply amazing, open source at the top of the top, like 95-96% of reasoning. So you basically are, if you have the means and your company requires that level of security, then you can do it. So now we are approaching, we are in the time series analysis now. Soon the distribution, the anomaly detection, and then we're gonna synthesize the findings. And now if I click here, you can begin to see a lot of the analysis that it's doing. So it's building upon what it found before, right? Yeah. So I'm not sure how is if you are keeping the score now. What is the conclusion? I don't know. What do you think? Is the global rising temperatures on Norway affecting the consumption of white wines and champagne, which is basically something that you will think that is obvious, because when it's very, very hot in Norway, you will like to drink more. So now comes the analysis, right? So let's read it together. A statistical analysis, temperature and wine cell hypothesis. Your hypothesis: rising temperatures due to global warming are pushing sales of white, rosé, and sparkling wines. And the verdict: partially supported. your hypothesis finds mixed statistical support. Here is a comprehensive evidence. Okay, so we have interpretation. The R is like is positive, but it's not like somebody will. There is a strong trend, but it's not like 100%. Like if you will say like 70%, not that correlated. So let's see. The finding: the summer, May, August temperature anomalies are significantly increasing over 2011 and 2025 at a rate of 0.09 standard deviation per year. Recent years have warmer summers than early years. Comparison from 2011 to 2017 versus 2018 to 2025. And I want you to look at it. The coin, you probably don't know that one, but the effect is huge. The recent period from 2018 to 2025 has significantly warmer summers than the early period. So let's keep reading. Yeah, okay. So the summer one correlate with temperature anomalies. And let's keep reading. This is really good. Like, if you like to play around with data, this is like a dream come true, to be honest. So now we have evidence against your hypothesis. Okay. Okay. And look what it found. Look what I found. This is amazing. Like, you really, really begin to appreciate the power of this thing. Without saying anything, it found the COVID effect is dominant. The massive spike in 2020 and 2021, where all the Norwegians were at home and were not able to buy alcohol in Sweden or at the airport or when they were drinking in somewhere other countries. It was driven by the COVID lockdown, not temperature. Amazing. Exactly. I didn't even read that one. Now it's there. So now you have a statistical summary table. You have the analysis type, the test type. So you see that you get a complete analysis that will have taken, honestly, to go to this depth. First, you will need to be very good at R. I use R for this kind of stuff, or Python. It doesn't really matter. But also, you need to have a very, very good imagination to expand basically the frontier of analysis. Like, you really need to be prospecting, like left and right and up and down, to cover all the possible analysis that you can do. So the final conclusion is very, very interesting. The final conclusion is your hypothesis is partially supported, but with important caveats. Supported are rising. Give me 1 second. Are rising. Super. The direct causal link is weak when controlling for time trend. Year time trend is a stronger predictor than temperatures. Then you have the COVID And then seasonality explained most varies. People always drink more wine in summer regardless of warming. What is the most accurate statement? This is amazing. While summer temperatures are rising and warmer than normal summers correlate with higher white rosé sparkling wine sales with an R of 0.6, the primary drivers of the 14-year sales increase are overall market growth trends, second, COVID-19 effects, and then seasonal consumption patterns. Temperature contributes, but it's not really the dominant trend. And finally, we get this even more. And so now I ask to create a document with all the findings, because if you cannot publish the findings, then what's the point? And I will say, can you render it? Can you render it? So one of the things that's very important is that you have the conversation, which is most likely not what you're gonna have. Only like you want to have this conversation and basically that's it. But you also want to have a document if for some reason you need to send this information to your manager or someone else. You can imagine that this kind of analysis is not about some a little toy play with the temperature, but it can be something else, like if you want to raise the price of a wine, what will be the consequences? Or if you want to prove something statistically, you will be using that one. And you will need to send that information to your customer, to your boss, or to your colleague. So let's see what we have. Let me just check, where is it? So now the analysis is done. And basically the analysis, and I'm going to, so it clearly states the hypothesis under investigation. It comes with a verdict. Really, really nice. You can see here the COVID, and it actually put it in highlights the COVID-19 effects. And it gives you a very, very good, how do you call it in English? I don't remember the word, grundlag, the basis of the analysis, basically. And it goes and on and on and on about the summer temperature analysis. You have this beautiful graphs and so on and so forth. Some errors here with the colors, but that's something that you can iterate. And even if you were to find an error in the analysis itself, you can just go back and say, you know what, I'm gonna say that this is not correct. You need to correct it. But I'm gonna leave it raw first try. This is not in reality. You will never take this at face value. You will probably iterate a bit more. But if you ask me, if you are a manager and this idea came to you, and somebody were to say, I really sold a lot this month, and the temperature in Norway was almost 40 degrees, you more likely than not, you're going to say, it's not that you sold a lot and you are the best salesman in the world. Most likely than not, the high temperature in the summer was the decisive factor, or not. But now you see what I'm trying to say. So yeah, we have some coloring issues here. So this is the kind of stuff that we can fix afterwards. But as you can see, here's the hypothesis, partially supported, and so on and so forth. And I know a lot of statisticians will kill me for putting a pie chart, but remember, this is not for a statistician. This is meant to have a conversation, and the way that you represent information is maybe a bit different of how you would like to do. And then you have a very nice ending here, telling you from where the information came from, the temperature data, which were the statistical methods applied, and the limitations. So very, very nice. And I will just put it in the web page as well, so you can read it yourself. Remember, I'm not going to touch it. I'm just going to leave it as is, so you can find errors if there's an error, or not. But the point remains that this is a conversational tool that allows you to rapidly iterate and get insight connecting to your databases and running this kind of analysis. So yeah, this was the analysis using our MCP server for statistics. And if you want to know more about our company, let me just put the web page right there. This is our company. We have the solutions here. Today you saw the statistical one, but we have also for revenue growth management, quantitative finance, and we have also advanced operations. And if you want to read something, just click on what's new, and it will you will be able to read this and this post. So thank you for watching, and see you soon.